So this question asks us to find the domain and range of these functions. So we first have f of x is 3x plus 2. Remember, domain, all possible inputs or x values, range, all outputs or y values. So fine, f of x is 3x plus 2. Are there any restrictions on what x could be? Well, I could plug in any real number I want, right? So my domain's got to be all reals. In interval notation, that would be minus infinity to plus infinity. How about the range? How about the outputs? Well, this is a line, right? We kind of visualize it. Y-intercept is 2, slope is 3. It looks something like that. So it goes as high as you want, it goes as low as you want. So my range also is all reals. Outputs, y values, get as big as you want, as low as you want. X values, get as far negative as you want, as far positive as you want. Range is also all reals, which is minus infinity to plus infinity. Always a good idea to look at the graphs of these things. So let's go to Desmos just to make the argument. So f of x is 3x plus 2. And we can see no restrictions on plugging in, no restrictions on things coming out. It grows and grows. Perceive arrows on the end of that line. Okay, our next question is g of x is 4 minus x squared. Now this is a little different. Are there any restrictions on x? Can I plug in positive numbers? Sure. Can I plug in negative numbers? Yeah. -5 quantity squared works. So I can plug in anything for x. So my domain will again be all reals. Range, well, it's a good idea again to think about what this looks like. And this is a parabola, looks something like this. So x values, any x values work, can be plugged in, but y values only go as high as this thing. Now, if you think about it, x squared is always a non-negative number. So 4 minus something, I guess x squared could be 0. So 4 minus 0 could be 4. But for any other value, your result is going to be less than 4. So your range are going to have values that are less than 4. So our y values for our range, less than or equal to, y would be less than or equal to 4. So in interval notation, it would look like this, right? And then headed this way for our range. And again, let's go ahead and look at Desmos just to make sure. So we have g of x is 4 minus x squared here. And we think about inputs and outputs. It gets as high as 4, does not go beyond 4. So negative infinity to 4 is my range. I don't think I've said that in interval notation. Let me go ahead and put an interval notation here. Negative infinity to 4 square bracket because it gets there. And then the domain again could be anything. As we see, any x value you want, you can plug into that function. What is our next question? 2 plus the square root of x minus 5. Now, we cannot take a square root of a negative number. That does not result in a real number, but a complex number. So my domain is going to do what? My domain is going to disallow anything that's going to make the thing under the square root negative. So my domain's got to give me what? X values that are greater than or equal to 5. 5 works, right? But I can't go below 5. So in terms of interval notation, that would be square bracket 5 to plus infinity. In terms of a number line, right here's 5. And it heads that way. That's my domain. Now, how about my range? The square root of x minus 5 is always a non-negative number. So 2 plus something positive is something bigger than 2. It could be 0, of course. So my range could include 2. So my range here, my y values would be greater than or equal to 2, but anything other than 5, 6, 7, 8, 9, that's going to grow. So my range is going to be from 2 plus infinity, or if you like, 2 to plus infinity that way. So let's go and take a look at Desmos and see what we get for that. So we have h of x equals 2 plus the square root of x minus 5. I guess I don't need the parentheses here. And you can see no x value is below 5. Now it gets to 5 too. That's as low as it goes. No x values below 5, so my x values go 5 to infinity. How about my y values? No y values below 2. 2 is the lowest y value I have. So indeed, domain 5 to infinity, range 2 to infinity, which agrees with what I said there. Okay, now what do we have? 5 minus absolute value of x minus 3, k of x. Let's do an analysis of that. Well, are there any restrictions on what we can plug in for x? Can you take the absolute value of x minus 3 if x is positive? Sure. X could be 7, 11, 13. If it's negative, negative 7 minus 3, sure, you take the absolute value of that. So no restrictions on x. So my domain is all reals again. Or minus infinity to plus infinity. Now the range is another story. Well, how are we going to handle the range? How low does it go? How high does it go? Absolute x minus 3 is a positive number. 5 minus a positive number is something smaller than 5. It could be 0, but it can get all the way up to 5 if it's 0. But if it's anything other than 3 here, this value is not 0. It's 5 minus something positive, which makes it smaller than 5. So my range would be y is less than or equal to 5, or negative infinity to 5 is what we would get there. So let's go ahead and take a look at Desmos and see what we have. What does that graph look like? Is that reinforced? So 5 minus absolute x minus 3, k of x equals 5 minus the absolute value of x minus 3. Notice no restriction on x. Domain could be all reals, but range up to 5. Does not go beyond 5, up to 5, which agrees with what I wrote here. So we're feeling pretty good about that. Okay, what do we have next? We have this function. What are the x values I see here? Open circle at -4, so we don't actually get there. Closed circle at 7. So the domain there would be round bracket at -4. The x value here is what we look at for domain. X value is -4, round bracket. And the highest it gets is 7. And that would be a square bracket. So my domain for this function would be round bracket -4 to 7. How about the range? How low does it get? How high does it get? The lowest value I see is, in the y's, is 4. There's a point here at 4. How high does it go? It gets close to 11, but not quite get there. Because of the open circle, it never actually gets to 11. So the y values range from, interesting use of words there, 4 to almost 11. So my range, square bracket 4 to almost 11, round bracket there, is what that will look like for that graph. And then our last one that we're going to look at is this one. What's my domain? Well, we're assuming this is an asymptote, and we're assuming y equals 2 is an asymptote. So I never actually get to 0. So my domain does not include 0 because of the asymptotic behavior, but it grows as far as you want. So my domain here, starting at 0 but missing 0, round bracket 0, going as far as you want, from 0 to infinity would be my domain of this one. Written that way. Now how about the range? How low does it go? How high does it go? Goes as high as you want. The y values will get to 11, 12, 100, 500. The y values get increasingly large, so the y values go to infinity. So we know this, comma infinity on the high range, high end of the range. Now how about the low end? How low does it get? Well, it's getting closer and closer to 2, but never quite getting there. right? We see our arrows, it's going to continue that way. We're assuming there's an asymptote here at 2. We're assuming it never quite gets there. So the range will be from 2 to infinity with a round bracket, right? Round bracket here. So the way we would write this otherwise, our domain here would be x is greater than 0 for that function. And the range would be y is greater than 2. For our previous example, which we did in interval notation, we'll just clarify that one more time. Domain from -4 to 7. So writing it this way, -4 is less than x is less than or equal to 7. Written that way. And our range goes from -4 to 11, not including, excuse me, +4 to 11, not including 11. So we say 4 is less equal x is less 11 would be the range for that one.